Welcome back everyone to this video. We are going to talk about half-range Fourier series. Half-range Fourier cosine series and half-range Fourier sine series. Generally, the functions we are considering are defined over the interval from minus pi to pi. Alright, that's minus pi less than x and x less than pi. That's what we are talking about. But in practice, we often encounter functions that are defined over half of this range, like from 0 to pi. Look at it. Minus pi, 0, pi. So we can also determine a Fourier cosine series or a Fourier sine series to represent that particular function. So that's what we are going to talk about in this particular video. Okay, so just keep watching. Remember to subscribe, like, and share this video to your friends and to your classmates. So in this video, we are going to find the half-range Fourier cosine series and the half-range Fourier sine series to represent this particular function that is defined in this interval from 0 to pi. Alright, so let's go ahead. Now, let us go with the first one. Let's determine the half-range Fourier cosine series to represent this function. F of x equal to 3x, 0 less than x less than pi. Since it is cosine series, okay, I'm starting with cosine series now, the first one. Since it is cosine series, we need an even function. Remember what we said about even and odd functions. For even functions, the series will contain cosine terms only and a naught. And for odd functions, it will contain sine terms only. Alright? So since we are talking about cosine series here, it means that the function in consideration is an even function. And so the Fourier coefficients that we need are a naught and a sub n. So for half range, a naught is 2 over pi from 0 to pi. Look at it, the integral from 0 to pi of f of x dx. A sub n is 2 over pi into the integral from 0 to pi, okay, of f of x cos nx dx. So let us determine a naught now, okay. A naught is 2 over pi times the integral from 0 to pi of what's f of x? 3x dx. So we have 2 over pi. The integral of 3x dx is 3x squared over 2 by the rule of integration. Alright? The integration is from 0 to pi. Okay? So let's evaluate that. This is it. 2 over pi. 3 over 2 is a constant, so it can come out. We have 3 over 2 into, we just have x squared left, okay? So let's evaluate the limit from here. Since we just have x squared left in this bracket, if we plug in pi first, we'll be having pi squared, okay? Pi squared minus. Plug in 0 now, we'll have 0. 2 can cancel 2, okay? Pi squared minus 0 is pi squared times 3 pi squared all over what? Pi. So 3 pi squared over pi is 3 pi. This is a naught. Because one of the pi here, we cancel 1 here. Since it is a product here, pi times pi. So this is our a naught as far as this function is concerned. What is a sub n now? A sub n is equal to this. 2 over pi times the integral from 0 to pi of f of x cos nx dx. What's f of x? 3x. So we have 3x cos nx dx. Okay, so 3 can come out. To multiply these two, we'll be having a sub n equal to 6 over pi into the integral from 0 to pi of x cos nx dx. To determine this, the integral of x cos nx dx, we are going to make use of integration by parts. Okay, so let's integrate it. Let's do it here. The integral of x cos nx dx. The integration by part formula says that the integral of u dv is equal to uv minus the integral of v du. Okay, so what is u here? What is dv? There is a mnemonic that we normally use to determine u and dv. That is LIATE. Logarithmic, inverse, algebraic, trigonometric, exponential. So here I have x, algebraic, cos nx, trigonometric. Algebraic comes before trigonometric. So u will be x since it is algebraic. That is the point. So my u is equal to x and dv is equal to every other thing there, cos nx dx. So the derivative of u with respect to x here, as du dx is equal to 1. Differentiate x with respect to x is going to produce 1. That means du is equal to what? Dx. Let's come to this place now. To get v, because we need v, we are going to integrate both sides. The integral of the v is v equal to the integral of cos nx dx is sine nx over n. So applying the formula uv minus integral v du, the integral of this now will be equal to cos u is x and this is v. That will be x sine nx over n minus the integral of v, this is v, that's sine nx over n. I can break it as 1 over n. du, what's du? dx. So this is what we are going to do now. This will now be a sub n equal to 6 over pi into, we have integrated x cos nx dx, and this is what it is. X sine nx over n minus 1 over n into the integral of what? Sine nx dx. The integration is from 0 to pi. So I can do something like this. From 0 to pi. From 0 to pi. I'm correct. So let's simplify further. This is all for the integration by parts. Let's continue with what we are looking for. So a sub n is equal to this now. 6 over pi, okay, into everything here in this bracket. In fact, everything here that we can see now, x and nx over n from 0 to pi is equal to 0. That is it. Because if we plug in the first limit as the upper limit, x, pi, plug in pi for x, we have pi sine n pi, okay? And sine n pi itself is 0. If we plug in 0, that will be 0 sine 0, which is still 0. So 0 minus 0 is 0. Everything here is out. This is what we have left. Minus 1 over n times this integral. So minus 1 over n can actually come out. We have something like this. Minus 6 over n pi. Yes. 6 times minus 1 is minus 6. Pi times n is n pi. So we are having just the integral of sine nx dx from 0 to pi. So we can take that integral. If we integrate sine nx dx, we are going to obtain minus cos nx over n. Okay? So minus cos nx over n from 0 to pi. So this is it now. Minus 6. Okay, check. Minus minus is a plus. N can come out to multiply n pi. So we'll be having this 6 over n squared pi into cos nx from 0 to pi. So let's plug in the upper and lower limits now. A sub n will be equal to 6 over n squared pi Plug in pi for x, we are going to obtain cos n pi minus, plug in 0, cos 0, since n times 0 is 0. So what is this equal to now? Cos n pi is equivalent to minus 1 to the power of n. Yes, I've explained this in one of my videos already under the same Fourier series. You can test it. So we have 6 over n squared pi minus 1 to the power of n minus cos 0 is 1. So let us determine the behavior of a sub n. This is a sub n. Let's determine the behavior of a sub n at different values of n, from n equal to 1 and so on and so forth. So when n is equal to 1, what's a1? When n equal to 1, plug in 1 here. Minus 1 raised to the power 1 is minus 1. Okay? Minus 1 is minus 2. So minus 2 times 6, that's what? Minus 12, then divided by n squared pi. Okay, n is 1, so divided by pi. Alright? What if when n is equal to 2? a2 minus 1 squared, n is 2 now. Minus 1 squared is 1. 1 minus 1 is 0. So 0 times what is here is still 0. So a2 is equal to 0. In fact, a2, a4, a6, a8, and so on and so forth, for n equal to even numbers, a sub n is 0. That is the point. So what is a3? What's equal to? Plug in 3 for n here. We'll have minus 1 raised to the power 3. Okay? Minus 1 to the power of 3 is still minus 1. So minus 1 is minus 2. Minus 2 times 6 is minus 12. So we're having minus 12 all over. Then 3 will be here. 3 squared is 9. That's 9 pi. Check something. When n equal to 1, a sub n was negative. When it's equal to 3, it's still negative. I can tell you that when it's equal to 5, it will still be negative. We'll be having this minus 12 over 25 pi. Check it. Plug in 5 here. That will be minus 1 to the power of 5, which is minus 1. Minus 1 is minus 2. Times 6 is minus 12. Then 5 squared is 25. That's it. So the thing is that for n equal to odd numbers, 1, 3, 5, 9, 7, and so on and so forth, a sub n is equal to this. For odd numbers, a sub n will be this. We have, look at it, minus 12 over n squared pi. That is it. Minus 12 over n squared pi. So the only difference is just for us to be plugging n. When n equal to 1, this will be 1 times pi, which is pi. Okay. When n equal to 3, it will be 9 pi. When n equal to 5, it will be 25 pi. That's just it. So for odd numbers, this is our a sub n. So this is what we need now to determine the Fourier cosine series of this function. Let's write it. Since the function, like we said, is an even function, because for cosine series, we are talking about even function, okay? So the Fourier series to represent this function will now be f of x equal to a naught all over 2 plus the summation from n equal to 1 to infinity of what? A sub n cos nx. Remember, b sub n is equal to 0 for an even function. So that one is out. So a naught is what? A naught is 3 pi. 3 pi over 2 plus, let us take the summation of this now from n equal to 1, 3, 5, 7. Because for n equal to 2, 4, 6, 8, a sub n is what? 0. So we are going to do away with those numbers. So when n equal to 1, what is a sub n? Minus 12 over pi. So we have minus 12 over pi cos 1x, that's cos s. When n equal to 2, it is 0. When n equal to 3, this is it, minus 12 over 9 pi, that's plus minus 12 over 9 pi cos 3x, okay. Let me put this one in brackets. Plus, when n equal to 5, it is this, minus 12 over 25 pi cos 5x. Okay, we can go on, we can continue. But let's stop here. The series is an infinite series. So let's simplify this. F of x will be equal to this. It's a naught 3 pi over 2. I can see that minus 12 over pi is common to all the terms in this bracket. So minus 12 over pi can come out, and we have here, we have what? Cos x. What we left here? 1 over 9 cos 3x. You get the point? We're having just 1 over 9 left. That's plus 1 over 9 cos 3x plus what's left here? That will be 1 over 25 cos 5x, and so on and so forth. So this is the half-range Fourier cosine series for this particular function. So let us go ahead now to determine the half-range Fourier sine series of this same function. This time around, we only need b sub n. Alright, let's go ahead. Subscribe, like, and share this video. Okay? Alright, for half-range Fourier sine series, we are talking about the sine series now. B sub n is 2 over pi times the integral from 0 to pi of f of x sine nx dx. For Fourier sine series, we are talking about odd function. Okay, you know that in an odd function, the series contains sine terms only. Alright, so the function here we are considering now is an odd function because we are determining the half-range sine series. In fact, not even half-range, the sine series in particular. That is the point. So for an odd function, we need just b sub n, and this is it. So let's determine b sub n for this function over this interval. B sub n is now equal to 2 over pi into the integral from 0 to pi of what's f of x? 3x. 3x sine nx dx. So if this theory comes out, we'll be having b sub n equal to 6 over pi, alright, into the integral from 0 to pi of x sine nx dx. So let us perform integration by parts to determine the integral of x sine nx dx. Just the same way we did for x cos nx dx when we determined the Fourier cosine series. Okay, so the integral of x sine nx dx. Using the integration by part formula, the integral of u dv is equal to uv minus the integral of v du. So just the same way we chose u and dv for x cos nx, okay, that's how we're also going to choose for x sine nx. X is algebraic, sine nx is trigonometric. So u will be x, u equal to x, and dv is what? Sine nx dx. So du is equal to 1 dx. Yes. And if we take the integral of both sides from here, the integral of dv is v, and the integral of sine nx dx is minus cos nx all over n. If you integrate the sine function, we are going to obtain the negative cosine. So what then is the integral of x sine nx dx? The integral of x sine nx dx will now be, what's UV? That's this times this, minus s cos nx over n, minus the integral of b, which is this. Okay, this is minus cos nx over n. This minus will come outside to affect this one to give us a plus. I will be having just cos nx over n. The 1 over n can come out. Yes, I can bring 1 over n out. Du is dx. So, in place of this now, we are going to write this. So, we have b sub n equal to 6 over pi into the integral from, okay, we have taken it already. We have minus x cos nx over n minus x cos nx over n plus 1 over n, the integral of cos nx dx, plus 1 over n into the integral of cos nx dx. The integration is from 0 to pi, from 0 to pi. So I can say from 0 to pi, from 0 to pi. Okay, so let's go ahead. B sub n is 6 over pi. Now, let's evaluate. Let's plug in pi for x here. Pi we enter and we obtain, this is minus pi cos n pi. Minus pi cos n pi over n minus. Let's plug in 0 now. That will be minus 0, which is 0. 0 cos 0 over n. Everything becomes 0 if we plug in 0 for x. So there's no need for that other term. That one is out. Then plus 1 over n. What is the integral of cos nx dx? The integral of cos nx dx is actually going to give us sine nx over n from what? 0 to pi. And everything here will give us 0. Yes. In fact, everything here, this whole integral is equal to 0. Because, check it now, if you plug in pi here, sine n pi, it's going to give us 0. Plug in 0, sine 0, it's going to give us 0. So 0 minus 0 is 0. Everything there will cancel out. If I want to erase it, since it's going to give us a 0, it's out. Okay? So this is what we have left for b sub n. And this is what? The minus can come out. In fact, pi can take away pi. Alright? The minus will come outside. We have minus 6 over n cos n pi. And I said earlier that cos n pi is equivalent to what? Minus 1 to the power of n. So b sub n is minus 6 over n into minus 1 to the n. This is it. So let's now determine the values of b sub n. That is the behavior of b sub n at different values of n, when n equal to 1, 2, 3, 4, and so on. Okay? So, b1, that is when n equal to 1. Plug in 1 here. Minus 1 raised to the power 1 is minus 1. So, minus 1 times 6 over 1, that will be minus 6 over 1 times minus 1. Alright? Which is equal to what? 6. What will be b2? Plug in 2 here. That will be minus 1 squared, which is 1. Alright? So we have minus 6 all over 2 into 1. Alright? Which is equal to what? Minus 3. Plug in 3 here. We are going to obtain minus 6 over 3 times minus 1. Because minus 1 raised to the power 3 is still minus 1. So minus 6 over 3 into minus 1. And this will give us minus is a plus. Okay. That's 6 all over 3, which is 2. Okay, let's determine b4. What will be b4? Let's stop at b5. B4 will be minus 1 to the fourth, which is 1, then minus 6 all over 4. So minus 6 over 4 times 1, minus 6 over 4 times 1. All right, and that will be what? Minus 6 over 4, which is equal to 2 here is 3, 2 here is 2. Let's stop at B5. Minus 1 raised to the power 5 is minus 1. Okay, so we have minus 6 times minus 1 over 5. Minus 6 times minus 1 over 5, which is equal to 6 all over 5. All right. Okay, let us determine the half-range Fourier sine series now. I don't need this anymore. Okay. For half-range sine series, since the series will contain only sine terms because it is odd, no a naught and no a sub n, the Fourier sine series will be equal to the summation from n equal to 1 to infinity of what? B sub n sine nx. So let us go now. When n equal to 1, what is B sub n? B sub n is equal to what? 6. Which is the same thing as saying 6 over 1. Alright, I want to write it as 6 over 1. You see the reason why. 6 over 1 sine 1x. Alright, that's sine x. Plus, when n equal to 2, what's B sub n? Minus 3. Alright, minus 3 is the same thing as saying minus 6 over 2. Yes, the reason is because I'm writing it in this way to contain 6 at the numerator so that I can factor it out later. So minus 3 is B2 and minus 3 is the same thing as saying minus 6 over 2. So we're having minus 6 over 2, okay, sine 2x. When n equal to 3, this is it. 2, B3 is 2. And this is the same thing as saying what? 6 over 3. 6 over 3 sine 3x. Okay, let's take one more. Plus, when n equal to 4, b sub n, which is b4, will be this, minus 6 over 4. So, minus 6 over 4 sine what? 4x. Alright? Okay, we can stop here. And so on and so forth. We can stop here. Let's finish it. So f of x will be equal to 6 is common all through. Okay, so I can bring 6 out. Open a bracket. Okay. What's here now? Sine x. Okay, so what's here now? We're having minus 1 over 2 sine 2x. Remember, the 6 is out already. Then plus, we have just 1 over 3 sine 3x left. Okay, let's go ahead. Okay, then what's left next? Minus, this will be minus 1 over 4 sine 4x. Sine 4x, and so on and so forth. So this is it for the half-range Fourier sine series to represent that function. Alright, so this is how to determine half-range Fourier sine and cosine series respectively. I hope you enjoyed the video. Keep supporting by subscribing to this channel, like the video and share it to your friends and your classmates as well. I'll see you in the next one.